Hello everyone, this is TK, and I have spent tomorrow morning and also last night trying to figure out the flash settings again. So this time it's for this very small STM32F042 series microcontroller. I'm planning to use this because it has a very small footprint, so I'm using this for the CAN encoder and also for my future servo controller. So it turns out that it has a bit different setting compared to the STM32G431 series I used for the beefier controller tasks. So here is what I have encountered, and I'm going to walk through that. So hopefully this can help you guys. Yeah. So for 042, it actually has two configurable regions. So firstly, there's the flash register, flash controller register. There's basic status, and what we are caring about is the SR and CR, the status and control registers, and also there are two two unlocking key register to write the key to it to unlock first the flash control and then the option byte control. But there's also so in the flash register there's a field called option byte register, I think, but it is a read-only register. These are all read-only, and it is mapped to the I forgot where it's stated, but it's mapped from the option byte register, which is at another memory section, which is here. It's in the option bytes description field. So we have the user read and protection option byte. This is what we care of. So this is the boot select control and boot select pin, and we also have two user data option byte. This is pretty nice. I can actually use this field to store the CAN ID of my device because the flash space is pretty limited. But basically, you can use this for any custom user data storing. And here's the last one, the write protection option byte. Okay, so for these registers, because these are non-volatile ones, so actually you cannot just write to it and call it a day. So in the user data sheet, it actually provides a sequence of, so we can just search for option byte programming, and it actually gives you some code to tell you how to erase the option byte and program the option byte. I was confused at first, so because firstly, this is not the HAL library syntax, it's just register manipulation, and in the datasheet it didn't specify when would you need to call the programming routine and when would you need to call the erasing routine. So it turns out that you need to call both. So this is the change boot selection piece of code I have written. So firstly, this is just a if statement to see whether we have the correct selection now, because for 042 microcontroller, when you launch the option byte, it actually resets the device. So we don't want the device to enter a infinite rewriting the configuration loop. So here is the termination condition. We just flash the LED to indicate the operation is finished. But here, so to change the option byte, you need to first unlock the flash setting. There's a very useful HAL flash unlock function to do it. Actually, let's enable this piece of code. Yeah, so you'll first call the flash unlock. It will help you to this one. It'll help you to write the 2 keys to the register. Yeah, and it will also verify if the flash is unlocked or not. And then you would unlock the option byte. So this is another set of key. And one thing to know that is like for STM32F041 and 042, the key for unlocking the flash is the same as this sequence, but the key for unlocking the option key is not. So yeah, you would need to refer to the datasheet. It might be different for like other STMs also. But basically, you would unlock the option byte, and then you would call the erase option byte routine first, because apparently those are non-volatile flash registers. So you need to first erase all the content before you can like change the content. So you will call erase using this routine. And now the option byte fields are all Fs. So they are not complementary anymore. And then you can write something to it. And then you call the program option byte routine. And one thing to know that is you need to change all of the option byte fields, even if you are like not changing the value from the previous one, because currently all the data are gone and like they're all erased. Yeah. And the place you would write the data to is the option byte registers, not the register mapped in the flash section. So you would use like these register addresses, like these, the 1Fs something. So there's a mapping in HAL, like it provides the option byte peripheral, which has these register fields. And another thing to note is that these are like half-word read and write registers. Okay, half-word write, but forward read registers. So you need to like write it like 16 bits at a time. So in the C++, in the C code, it actually maps to like Uint 16T, but like when you are manually recovering the settings, you will also like map it to Uint 16T to make it work. Yeah, and after that, it's pretty straightforward. You need to disable the other chain settings bit you have made, and then lock and reload option byte. Like and also here's the difference. So for this one, you need to lock the flash first before calling option byte launch, because like this one it will reset automatically the MCU. But for G431, so from my previous attempt, it seems that we need to first call the launch option function and then lock the flash. And like for 431, it will not reset the MCU. So that's a bit confusing, but well, there it is. And then after reset, the MCU will reboot, and hopefully with the correct changing loaded, so then it will enter this like just a simple blinking LED to indicate it's finished what it has to do, just like here. Yeah. And yeah, and that's basically it. Like last night I was struggling with the unlock option byte field, because like in the debugger, when you are writing incorrect key to the register field, the write will actually cannot pass through. So the debugger will prompt you like cannot write to that register region unless you write it with the correct key. So that's one thing that is very confusing, and I have spent a lot of time on it. But yeah, that's all. Thank you.